Most smart home systems announce themselves. Hubs blink on countertops, voice assistants squat on nightstands, tablets get bolted to walls like digital billboards. But here's the thing, the best automation is the kind you never see. My name's Keiko Tanaka, and I spend my days designing what I call invisible intelligence, smart home tech that works so seamlessly into your space, guests don't even realize it's there. Today, we're talking about building that kind of system using a circuit board the size of a business card.
You're listening to Smart Home Setup Podcast. Quick heads up, the voice you're hearing right now is AI generated, but everything else, the research, testing, the writing, that's all me, Keiko Tanaka, a real person who's spent years wiring smart tech into homes so it disappears. If you've been listening for a while, thank you. Seriously, it's great knowing there are people out there who care about this stuff as much as I do. If you're new, welcome aboard. We release new episodes every Monday, Wednesday, and Friday, and each one digs into a different corner of smart home design. Now, let's talk about building a home automation system that nobody will ever see.
The beauty of Raspberry Pi Zero home automation lies not in the device itself, a modest circuit board the size of a business card, but in how completely it can disappear. Over the past decade, I've watched clients grow weary of smart home setups that announce themselves. Tablets mounted on walls, hubs blinking on countertops, voice assistants perched on nightstands like digital sentries. The Raspberry Pi Zero offers a different path. Tuck it behind a bookshelf, nest it inside a console table, mount it beneath a floating credenza, and from that hidden position, orchestrate lighting shifts, climate adjustments, and presence detection that feels intuitive rather than technological. This guide walks you through building a Raspberry Pi Zero home automation system that prioritizes lived experience over visible gadgetry. You'll learn to select protocols that suit your existing architecture, configure the logic that drives daily rituals, and troubleshoot the friction points that separate reliable automation from experiments that frustrate. Expect to spend a focused weekend on initial setup, longer if you're routing cable through walls or integrating legacy devices, but the foundation you build will support years of refinement. Skill level-wise, you should be comfortable with command line interfaces and basic networking concepts. You don't need programming fluency, but you should be willing to edit configuration files and follow structured syntax. Let's start with what you'll need. On the hardware side, you want the Raspberry Pi Zero 2W, specifically the 2W variant. The original Zero struggles with multi-protocol coordination. Check the show notes for a link to the current price. You'll also need a micro SD card, 32 gigs minimum, class 10 or better, a USB power supply, 5 volts at 2.5 amps with a micro USB connector, a Zigbee USB coordinator stick, either the Sonoff Dongle E or ConB2. Avoid generic adapters, they introduce latency spikes. Or, if your existing devices require it, a Z-Wave USB stick, like the IoTech Z-Stick 7. Just know that Z-Wave mesh networks add approximately 40 to 80 milliseconds of latency versus Zigbee's 20 to 30 milliseconds. An Ethernet adapter is optional but recommended for initial setup. Wi-Fi configuration can be finicky on first boot. Software-wise, you need the Home Assistant OS image. Download that from the official Home Assistant website. Balena Etcher or Raspberry Pi Imager for flashing the micro SD card, and an SSH client, terminal on Mac or Linux, PuTTY on Windows. Now, about your existing smart home devices. For Zigbee, think Philips Hue bulbs without the Hue bridge, IKEA trad-free motion sensors, Aqara door and window sensors. For Z-Wave, GE or Jasco in-wall switches, Fibaro motion sensors, Yale smart locks. Wi-Fi devices like TP-Link Casa smart plugs or Shelly relays, these connect directly, no hub required. Thread and Matter devices include Eve energy plugs and Nanoleaf bulbs. As of 2026, Matter support in Home Assistant is stable but still maturing. Expect occasional firmware updates. The Raspberry Pi Zero 2 acts as the central hub, replacing proprietary ecosystems like SmartThings or Habitat. This consolidation means fewer apps, fewer cloud dependencies, and faster local processing. Most automations execute in under 100 milliseconds when devices share the same protocol. Now, let's talk about flashing and configuring the base system. Download the Home Assistant OS image specific to the Raspberry Pi Zero 2W. Open Balena Etcher, select the downloaded image, choose your microSD card, and flash. The process takes 3 to 5 minutes. Before removing the card, create a network folder in the boot partition and add a file called My Network with your Wi-Fi credentials. The format looks like this: a connection section with ID equals My Network, type equals Wi-Fi, a Wi-Fi section with SSID equals your network name, mode equals infrastructure, a Wi-Fi security section with key management equals WPA-PSK, PSK equals your password, and IPv4 and IPv6 sections, both set to method equals auto. This pre-configuration sidesteps the need to connect a monitor and keyboard. The Pi will join your network on first boot. Insert the microSD card, connect power, and wait 8 to 10 minutes. Home Assistant initializes slowly on the Zero 2W. Patience here prevents false troubleshooting later. Navigate to homeassistant.local:8123 in a browser. If that address fails, check your router's connected devices list for the Pi's IP and use that directly. Create your admin account, name your home, and set your time zone. The onboarding process auto-detects some devices. Ignore these for now. We're building from the foundation up, not accepting defaults. For invisible integration, mount the Pi inside a shallow drawer beneath a console table or behind a picture frame with ventilation gaps. The device generates minimal heat, under 50 degrees Celsius at idle, so passive cooling suffices. Run a single micro USB cable to a hidden outlet or use a power over Ethernet splitter if you've added the Ethernet adapter. The goal is zero visible hardware, only the effects of automation. Moving on to installing protocol integrations and USB coordinators. Plug your Zigbee or Z-Wave USB stick into the Pi's micro USB port using an OTG adapter. Home Assistant should detect the hardware automatically, but protocol support requires explicit integration.
Navigate to Settings, Devices, and Services. Add integration. Search for Zigbee Home Automation, that's ZHA if you're using a Zigbee stick, or Z-Wave JS for Z-Wave. Follow the prompts to select the USB device path, usually /dev/tty-USB0 or /dev/tty-ACM0. ZHA configures in under a minute. Z-Wave JS requires an additional container download that takes 2 to 3 minutes on the Pi Zero W2. For Wi-Fi devices, search for brand-specific integrations, TP-Link Casa, Shelly, Tuya, and authenticate with your device credentials. These integrations poll your local network, no cloud relay required. Expect 200 to 500 millisecond response times for Wi-Fi devices versus 20 to 80 milliseconds for Zigbee and Z-Wave, a perceptible difference when dimming lights or triggering scenes. If you're incorporating Thread or Matter devices, install the Matter Beta integration. Pair each device through its manufacturer app first, then share it to Home Assistant via the Matter protocol. As of 2026, cross-brand Matter reliability hovers around 92%. Impressive, but not flawless. Keep manufacturer apps installed as fallback control paths. Latency expectations. Zigbee commands execute fastest, 20 to 30 milliseconds typical. Z-Wave next, 40 to 80 milliseconds. Wi-Fi slowest,
200 to 500 milliseconds, depending on network congestion. Thread and matter latency matches Zigbee when devices are within 3 hops of the border router, your Pi, but degrades beyond that. Design automations with these timing realities in mind. Wi-Fi switches work fine for single-action triggers, but feel sluggish in multi-step scenes. Now let's talk about pairing devices and building your mesh network. Begin pairing devices closest to the Pi, then work outward. This builds your mesh network concentrically, ensuring each new device has a strong parent node to connect through. For Zigbee, navigate to the ZHA integration, click Add Device, and put your sensor or bulb into pairing mode, usually a 5-second button hold. The device appears within 30 seconds. Repeat for each Zigbee device, waiting 60 seconds between pairings to let the mesh recalculate routes. For Z-Wave, open Z-Wave.js, click Add Node, and trigger pairing on your switch or lock. Consult the device manual because methods vary. Z-Wave pairing is slower, expect 1 to 2 minutes per device, and more finicky about proximity during the initial handshake. Bring the Pi to the device location if necessary, then return it to its permanent spot and perform a heal network action overnight to optimize routes. For Wi-Fi devices, most auto-discover on your network. Check the integration page for any that don't appear automatically and add them by IP address.
Place powered devices, smart plugs, in-wall switches, hardwired bulbs strategically. These act as mesh repeaters, strengthening signal for battery-powered sensors further away. I once resolved a client's unreliable motion sensor by relocating a Zigbee smart plug from their kitchen to a hallway outlet 15 feet closer. The sensor's latency dropped from 2.3 seconds to 180 milliseconds. Mesh reliability factors. Zigbee and Z-Wave both self-heal, but Zigbee does so dynamically while Z-Wave requires manual network healing after adding devices. If you're mixing protocols, prioritize Zigbee for sensors that trigger time-sensitive automations, lighting transitions, door chimes, and reserve Z-Wave for high-security devices like locks, where encryption overhead justifies the latency trade-off. Next up, designing automations that feel like intuition. Automation logic transforms a collection of devices into a cohesive environment. The syntax is straightforward: trigger, condition, action. The artistry lies in choosing triggers that align with natural behavior patterns, not just technical capability. Navigate to Settings, Automations and Scenes, Create Automation, start with an empty automation. Here's a foundational example I use in nearly every project. Morning Light Cascade. The trigger is time is 6:45 a.m. The condition is sun elevation is below 10 degrees, which ensures it only fires on dark mornings. The actions: bedroom, dim Zigbee bulbs to 5% warm white at 2700 Kelvin, half-second fade. Wait 60 seconds. Hallway, turn on Zigbee bulbs to 20%, 2-second fade. Wait 90 seconds. Kitchen, turn on under cabinet LED strip to 40%, 3-second fade. In syntax terms, if time equals 6:45 and sun elevation is less than 10 degrees, then turn on bedroom main light at 5% brightness, 2700 Kelvin, half-second transition. Wait 60 seconds, turn on hallway main light at 20% brightness, 2-second transition. Wait 90 seconds, turn on kitchen under cabinet light at 40% brightness, 3-second transition. The staggered timing creates a gradient of wakefulness that feels like natural sunrise rather than abrupt illumination. Adjust fade durations and brightness percentages until the progression suits your household's rhythm. Here's another one: presence-aware climate adjustment. Trigger is front door contact sensor changes to open. Condition is no motion detected in any room for 30 minutes, indicating departure, not arrival. Actions: set thermostat to 68 degrees Fahrenheit in winter or 78 in summer. Turn off all lights except porch and entry. Arm security system to away mode. In syntax, if front door sensor equals open and living room motion sensor's last change was more than 30 minutes ago, and bedroom motion sensor's last change was more than 30 minutes ago, and kitchen motion sensor's last change was more than 30 minutes ago, then set main thermostat target temperature to 68 degrees. Turn off all interior lights, excluding porch and entry. Arm main alarm control panel to away. This automation requires multi-sensor confirmation to avoid false triggers when someone steps outside briefly. The condition checks motion history across multiple rooms, a reliability safeguard that prevents the system from thinking you've left while you're reading in a quiet room. Fallback behaviors matter. Every automation with a trigger that could fail, network hiccup, dead sensor battery, firmware glitch, needs a fallback. For the climate example above, I add a secondary time-based check. If time equals 9 a.m. and main thermostat current temperature is less than 65 degrees, then set main thermostat target temperature to 70 degrees and send a mobile app notification saying morning temperature override triggered, check automation logic. This catches mornings when the door sensor didn't fire or motion detection misfired, ensuring you don't return to a cold house. For those building a first system from scratch, the fundamentals of starting smart home from scratch step by step, check the show notes for that link. Provide broader context on sequencing device additions and avoiding protocol conflicts. Now, let's get into configuring voice control without visible assistants. Voice assistants typically require dedicated speakers, the antithesis of invisible design. The Pi 02W can't run local voice processing, it lacks the CPU headroom, but it can relay commands to cloud-based assistants without placing physical devices in living spaces. Install the Alexa Media Player or Google Assistant SDK integration, link your Amazon or Google account, then configure routines within those ecosystems that trigger Home Assistant scenes via webhook URLs. Example workflow. In the Alexa app, create a routine. Alexa, bedtime, triggers a custom action, webhook URL pointing to Home Assistant's /API/webhook/bedtime scene. In Home Assistant, create a webhook automation that listens for that URL and executes turn off all lights except bedroom, dim to 10%, shift to 2200 Kelvin. Lock front door, that's a Z-Wave lock with latency around 1.2 seconds, set thermostat to 65 degrees, arm security system to night mode. The voice processing happens on Amazon servers. Your Pi merely receives the final command. You speak to your phone, the automation executes, and no Echo Dot sits on your nightstand.
Latency cloud-based voice commands add 800 to 1.5 seconds compared to local triggers. That delay is imperceptible for scene activation, but frustrating for rapid toggling. Use voice for infrequent, multi-step routines. Rely on sensors and time-based triggers for moment-to-moment responsiveness. Interoperability limitations. Alexa and Google Assistant handle Zigbee and Wi-Fi devices directly, but Z-Wave devices require Home Assistant as a bridge. If you've invested heavily in Z-Wave switches, expect to route all voice commands through Home Assistant rather than native assistant skills. This works reliably, but adds configuration overhead. For households concerned about phantom power draw across multiple protocol coordinators, smart home power monitoring systems, link in the show notes, can quantify actual consumption. The Pi 02W with a Zigbee stick typically pulls 1.2 to 1.8 watts continuously. Moving on to concealing wiring and sensors in architectural details, the technical setup is half the equation. Physical integration determines whether your Raspberry Pi Zero home automation system enhances ambiance or disrupts it. Motion sensors.
Standard motion sensors, white plastic domes screwed to ceilings, broadcast their presence. Instead, recess millimeter wave presence sensors, check the show notes for a link, into ceiling coffers or behind acoustically transparent fabric panels. These sensors detect micro-movements, breathing, typing, rather than requiring gross motion, so they work even when someone sits still reading. Mount them 7 to 9 feet high for optimal coverage, angled towards seating areas. Trade-off: millimeter wave sensors cost 3 to 4 times more than passive infrared options, and occasionally false trigger from ceiling fan motion. Adjust sensitivity in the device settings until the balance feels natural. Door and window sensors. Embed reed switch sensors within the door jamb itself, rather than surface-mounting contact sensors. This requires routing thin wire through the jamb cavity, simple during new construction, tedious in retrofit scenarios. For existing homes, place sensors on the hinge side of the door where they align with the jamb profile and blend into shadow. For French doors or full glass entries, where any sensor reads as clutter, substitute vibration sensors, Zigbee protocol, adhered to the interior glass pane. These detect the mechanical disturbance of opening, but don't require a second magnet contact, reducing visible hardware by half. Temperature and humidity sensors. Tuck these behind floating shelves, inside decorative objects with ventilation, like ceramic bowls or wire baskets, or beneath furniture overhangs. The sensor needs air circulation, but not direct visibility. I've nested them inside the hollow bases of table lamps, routed the Zigbee antenna through a drilled hole, and achieved readings within 0.3 degrees Celsius of exposed placement.
Reliability factor. Concealed sensors collect dust more rapidly, and dust acts as thermal insulation, skewing temperature readings by 1 to 2 degrees Celsius after 6 months. Scheduled biannual cleaning, or accept the drift and calibrate periodically. Cable management. Route USB cables and Ethernet behind baseboards using adhesive-backed channels, or surface mount them along trim edges in the same finish as your wall color. The Pi itself can live inside a credenza, nightstand, or media console, anywhere with passive airflow and proximity to a power outlet. Avoid fully sealed cabinets. The Pi's modest heat output still needs dissipation. Now let's talk about testing, iterating, and building fallback routines. Your first automation suite will feel clumsy. Lights that fire too bright, sensors that miss your presence, voice commands that misfire. This is expected. Inhabit your space for a week. Note every moment of friction, then revise. Testing protocol. For each automation, trigger it manually from the Home Assistant interface to test the action logic. Wait for the natural trigger condition to test the real-world sensor behavior. Intentionally break the trigger, disconnect a sensor, block motion detection, and observe fallback behavior. Example friction point I encounter often: motion-activated lighting in hallways that turns off while you're standing still. Standard PIR sensors time out after 60 seconds of no motion, plunging you into darkness mid-task. The fix: if hallway motion sensor equals detected, then turn on hallway main light at 60% brightness and start a timer called hallway occupancy for 5 minutes. If hallway motion sensor equals clear and timer hallway occupancy is finished, then turn off hallway main light with a 3-second transition. This extended occupancy timer keeps lights on for 5 minutes after the last detected motion, bridging the gap when you pause to check your phone or tie a shoe. Fallback routines. Every automation with external dependencies, cloud APIs, internet connectivity, battery-powered sensors, needs a graceful degradation path. If the Zigbee coordinator disconnects, revert critical lights to manual control via physical switches. Install Zigbee switches that retain last known state even when the coordinator is offline. If Home Assistant crashes, use smart plugs with local firmware timers. Shelly devices support this. To maintain basic schedules: outdoor lights on at dusk, off at dawn, independent of the Pi. If motion sensors go offline, fall back to time-based automations.
If motion hasn't been detected in the living room by 10 p.m., assume occupancy and leave path lighting active. The best Raspberry Pi Zero home automation systems are those you don't notice, and that includes failures. You should never stand in a dark hallway waiting for a mesh network to heal itself.
For deeper exploration of how different protocol stacks coexist or conflict within a single hub, Multi-Protocol Smart Home Hubs, link in the show notes, addresses interoperability pitfalls across Zigbee, Z-Wave, Thread, and Matter. Next, monitoring system health and planning maintenance windows. The Pi Zero W2 runs reliably for months without intervention, but Raspberry Pi Zero home automation requires periodic attention to sustain performance. Weekly checks. Review the Home Assistant system log for warnings about failed device communications or integration errors. Check battery levels on wireless sensors. Most Zigbee sensors report battery percentage. Replace or recharge anything below 20%. Verify automation execution times. If a routine that normally fires in 80 milliseconds suddenly takes 2.3 seconds, your mesh network may be congested or a repeater device has gone offline. Monthly maintenance. Update Home Assistant OS and integrations. Navigate to Settings, System, Updates. Stage updates for mid-morning when you're home and can troubleshoot if something breaks. Major version updates like 2026.1 to 2026.2 occasionally introduce breaking changes to custom integrations. Read the release notes first. Reboot the Pi. Home Assistant's memory footprint grows slowly over time. A monthly reboot clears caches and restarts all services cleanly. Schedule this for 3 a.m. when automations are least active. Quarterly deep dive. Heal Z-Wave networks if you're using Z-Wave devices. Perform a full network heal. This recalculates optimal routes and can shave 30 to 50 milliseconds off command latency. Audit unused devices and integrations. Deprecated devices clutter the interface and consume CPU cycles. Remove any hardware you've decommissioned. Backup configuration. Home Assistant includes a built-in backup tool at Settings, System, Backups. Download a copy to an external drive. Recovery from a corrupted micro SD card takes 5 minutes if you have a recent backup, 2 days if you don't. Reliability over time. The Pi Zero W's micro SD card is the lifeblood of your system and its Achilles heel. Consumer-grade cards fail after 8,000 to 10,000 write cycles, a threshold you'll approach within 2 to 3 years of logging sensor data every few seconds. Migrate to an industrial-grade micro SD card, SanDisk High Endurance, Samsung Pro Endurance, rated for continuous write operations. These cost marginally more but last 3 to 5 times longer. Invisible alternative. House the Pi inside a media console with ventilated sides, alongside your router or modem. The uniform blinking LEDs blend together, and the entire stack reads as network infrastructure rather than smart home hub. Label the Pi's power supply with a small engraved tag, so future you or a technician knows which cable not to unplug.
Let me share some pro tips and common mistakes. Start with lighting, not security. Lighting automations forgive mistakes. You flip a switch manually and move on. Security automations that fail, a door that doesn't lock, a camera that doesn't record, erode trust in the entire system. Build confidence with low-stakes routines before layering in high-consequence devices. Name devices descriptively, not generically. Living room lamp is clearer than bulb 3. 6 months from now, when you're troubleshooting an automation at midnight, you won't remember which numbered bulb corresponds to which fixture. Use room names, fixture types, and cardinal directions. Bedroom east sconce, kitchen under cabinet south. Avoid chaining Wi-Fi devices in time-critical automations. A motion sensor triggering a Wi-Fi bulb introduces 200 to 500 milliseconds of latency. That delay feels sluggish. Lights that respond a half second after you enter a room read as laggy, not intelligent. Use Zigbee or Z-Wave for anything requiring sub-100 millisecond response times. Test automations during the conditions they're meant to handle. An automation that dims lights at sunset works beautifully in summer when sunset occurs at 9 p.m. and you're awake to observe it. In winter, when sunset arrives at 4:30 p.m. and you're commuting home, that same automation might fire while the house is empty, wasting energy and giving the illusion of occupancy you didn't intend. Add occupancy conditions, motion detected in the past 30 minutes, to prevent this. Common mistake: pairing battery-powered Zigbee sensors too far from powered repeaters during initial setup, then wondering why they drop offline after a week. Battery devices conserve power by checking in with the network infrequently. If the signal path is marginal during pairing, it becomes unusable once the device enters deep sleep mode. Pair near a powered device, then relocate if needed. Common mistake: installing 15 integrations on day 1, then struggling to isolate which one is causing intermittent crashes. Add integrations sequentially, run the system for a day between additions, and monitor the system logs page for errors. Home Assistant is modular and tolerant, but some integrations pull cloud APIs aggressively and overwhelm the Pi Zero's modest CPU. Invisible integration: if a spouse or housemate resists smart home technology on aesthetic grounds, begin with felt, not seen improvements. Automated bathroom fan shutoff after humidity drops, closet lights that turn on when the door opens, a bedside lamp that dims gradually over 10 minutes before your alarm. These enhancements dissolve objections because they solve friction without introducing visual clutter. Let's wrap up with some frequently asked questions. Can the Raspberry Pi Zero W, original, not the 2W version, handle Home Assistant reliably? The original Pi Zero W struggles with multi-protocol coordination and becomes sluggish once you pair more than 8 to 10 devices. Home Assistant's interface loads slowly, 10 to 15 seconds per page, and automations fire with noticeable delays, often 1 to 2 seconds after the trigger condition. The Pi Zero 2W's quad-core processor resolves these bottlenecks, handling 30 to 40 devices comfortably with sub-100 millisecond automation response times. If you already own the original Zero W, it can run a minimal setup, Zigbee coordinator plus 10 devices, but plan to upgrade within 6 months as your system grows. How do I migrate from a proprietary hub like SmartThings to Raspberry Pi Zero? Let's wrap up with some frequently asked questions. Can the Raspberry Pi Zero W, original, not the 2W version, handle Home Assistant reliably? The original Pi Zero W struggles with multi-protocol coordination and becomes sluggish once you pair more than 8 to 10 devices. Home Assistant's interface loads slowly, 10 to 15 seconds per page, and automations fire with noticeable delays, often 1 to 2 seconds after the trigger condition. The Pi Zero 2W's quad-core processor resolves these bottlenecks, handling 30 to 40 devices comfortably with sub-100 millisecond automation response times. If you already own the original Zero W, it can run a minimal setup, Zigbee coordinator plus 10 devices, but plan to upgrade within 6 months as your system grows. How do I migrate from a proprietary hub like SmartThings to Raspberry Pi Zero home automation without repairing every device? Zigbee devices can be migrated directly if you perform a coordinator backup before removing the old hub. In Home Assistant's ZHA integration, use the Migrate Radio tool to transfer the network key and device list from your SmartThings hub's Zigbee coordinator to your new USB stick. This preserves pairings for 80 to 90% of devices. A handful may require repairing due to manufacturer-specific quirks. Z-Wave devices require exclusion from the old hub and re-inclusion on the new one. There's no direct migration path. Wi-Fi devices switch instantly, since they don't rely on a hub at all. What happens to my automations if the internet goes down but my local network stays up? Home Assistant processes automations entirely on the Pi, no cloud dependency. Zigbee, Z-Wave, and locally controlled Wi-Fi devices, Shelly, Casa with local control enabled, continue functioning normally.
Voice commands routed through Alexa or Google Assistant fail because those require cloud processing, but sensor-triggered and time-based automations execute without interruption. The exception, integrations that pull data from external APIs, weather services, calendar syncing, will stale until connectivity returns, but they won't crash the system. How much power does a Raspberry Pi Zero home automation setup consume, and will it increase my electricity bill noticeably? The Pi Zero 2W draws 0.4 to 0.8 watts at idle and 1.2 to 1.8 watts under moderate load, 20 Zigbee devices, 5 active automations. A Zigbee USB coordinator adds 0.2 to 0.4 watts. Running 24/7, the combined system consumes approximately 15 to 20 kilowatt-hours annually, around $2 to $3 per year in most North American markets. By comparison, leaving a single 60-watt incandescent bulb on for 8 hours daily consumes 175 kilowatt-hours annually. The Pi's energy footprint is negligible, and if your automations reduce lighting or HVAC waste by even a few %, the system pays for its own consumption within weeks.
The Raspberry Pi Zero W2 won't win design awards. Its bare circuit board and exposed components feel utilitarian, almost austere. But that humility is precisely why it succeeds where branded smart home hubs fail. It doesn't demand center stage. Concealed behind furniture, mounted beneath surfaces, or nested inside architectural voids, the device becomes infrastructure rather than ornament. The automations you've built, lighting that shifts with daylight, climate that adjusts to presence, security that arms itself when you leave, recede into the background of daily life. Guests won't ask about your smart home setup because they won't perceive it as a setup at all. They'll simply notice that your home feels responsive, that transitions between rooms happen smoothly, that the environment adapts without announcement. That responsiveness requires ongoing refinement. The Raspberry Pi Zero home automation system you deploy this weekend is version 1, a functional foundation. Over months, you'll discover new friction points, a hallway that stays dark too long, a thermostat that overcorrects, a voice command that misfires. Each adjustment sharpens the system's intuition until the gap between intent and action narrows to imperceptibility. The technology exists to serve ambiance, not replace it. When light dims gradually rather than clicking off, when temperature shifts preemptively rather than reactively, when doors lock themselves after you've left, these are gestures of attentiveness, not intrusion. Your home becomes a collaborator in daily rituals rather than a passive stage, and the device orchestrating that transformation remains exactly where it belongs, hidden, silent, and tireless. Thanks for listening to this episode of Smart Home Setup Podcast. New episodes come out every Monday, Wednesday, and Friday, so there's always something fresh coming down the line. If you got something out of this one, I'd really appreciate it if you leave a 5-star rating and write a quick review. It genuinely helps other people find the show, people who are probably standing in a dark hallway right now wondering why their motion sensor just quit. And if you haven't already, hit subscribe or follow so you get notified the second a new episode drops. See you next time!